All right, guys. How are you guys doing? Are you staying well, staying healthy, staying around other people that are healthy, staying around other people that's the key, that's the key. It's supposed to be cold this well, cool this okay, let's go through, well, let's stand up, stand up. Oh, I cannot wait to teach again without masks and to teach students without masks. Okay, let's sit back down. Now, let's see what's in your head. I want you to write down from memory product rule. Quotient. Power. And now the one we talked about last time, power chain rule. Power chain rule. Okay, without breathing on each other, share what you have with somebody else. Share what you have with somebody else. You can just call them out.
Not that I can see anything. Times to the k minus 1 times f of x prime.
Yeah, k minus 1.
Okay. What do you have for the derivative of f times g?
F prime of x times g of x plus f of x times g prime of x.
Anybody get that? Okay, when I said quotient rule, what was on the left-hand side? When I said quotient rule, what did you have on the left-hand side? Okay, then what do you have on the right-hand side? Probably need to start out prime of x times g of x, and then notice again, these are identical except for the minus. So you always want to start with f prime. It doesn't matter in product rule. you'll get the same answer, but it does matter in quotient rule. Then am I done? Am I done with this?
No.
What goes on the bottom? Now, when I said power rule, what was on the left side of power rule? What is on the left side of power rule? X to any real number, the derivative of that is
K
times
minus
X,
K
K minus 1, K minus 1. And then the hardest one was power chain rule. Power chain rule. What was on the left-hand side for power chain rule? F of X raised to the K. And we want the derivative of that. We want the derivative of that. And it's a lot like power rule. It's a lot like power rule. We have a K and then a to the
K minus 1.
then times
F prime of X.
times F prime of X. So these really, some of the other flashcards are important, but these are the main four that really you have to have for derivative. The other one is tangent line. When I say tangent line, you say
Equals F prime of C times X minus.
times X minus C. Okay, so what we're gonna do is we're gonna go into your book and we're gonna look at some problems, some exercises that are similar to the ones that I've assigned, where we use these flashcards. And I'm gonna show you guys have actually learned quite a bit. So this is in the chain rule section. Let's look at one like number 3. Let's look at number 3. Your eyes are better than mine. Can you read what number 3 has there? Can you guys see that at all?
X equals X squared plus 2 to the fifth.
F of X equals X squared plus 2 to the 5th. Which flashcard would you want to use to start that one? Which flashcard would you want to use to start that one? Power chain. So you guys try that. Try to see if you can't take the derivative of that. See if you're facing number 3 on a quest, would you be able to handle that? Let me see if I can make that bigger. Is that better? Is that better?
Yeah.
Okay, you guys help me out. Who's the K? Who's the K in that rule? Who's the K in that rule for this one? 5. Who's the F of X? Who's the F of X?
Squared plus 2.
So look around. See, ask somebody what they got. Ask somebody what they got. You gotta ask somebody.
What'd you guys get? I'm like so. What'd you get? 5 X squared plus 2 to the 4th times 2X.
Okay, what do you guys have as your answer? What do you have as your answer? You would have a 5, then a to the 4. Now, are you done?
No.
The chain reaction part, times 2x. You know, that one, where's the 2x coming from? What's the derivative of x squared plus 2?
2X.
Now the book isn't going to leave it like this. It's going to take the 5x times the 2x times the 5 and give you a 10x. And so let's just use their drop-down menu. And do you guys see how you guys got the right answer? Do you guys see? Now on a quest, you have the right answer here. On a quest, you have the right answer there. You guys, I mean, does that work? Does that work so far? Okay, so now let's go down to number 9. Let's go down to number 9. Now I want to take the derivative of, want to take the derivative of x squared minus 4 to the 5 halves. Is 5 halves a real number? Is 5 halves a real number? Yes. Okay. I can use power rule and I can use power chain rule on that. So try to take the derivative of that. Try to take the derivative of that using your power chain rule. I would just so love to walk around the room. Like this whole 6 feet that I've got to stay 6 feet away is almost impossible. Okay, just share. Just say if you got the same thing. See if you got the same thing as somebody else. I know what probably should be this way.
Would be it. That's where mine's
Okay, for sake of time, if you're using the power chain rule, how many people think of like instinct-wise, like if you're my linebackers, and I'm saying, okay, you're thinking about which flashcard to use with a linebacker, what defense to play. How many people recognize it's not product rule? How many people recognize it's not product rule? It's not a quotient rule. How many people recognize that? We're not going to start with that. How many people see it's a power chain? Okay, who's the K? Who's the K? Okay, and who's the f of x? So when you're taking the derivative, it would be 5 halves. Now here's the hard part for everybody. 5 halves minus 1 would be 3 halves. Am I done? Am I done? What's the derivative of the inside? 2x. Now if you simplify, what would happen with those guys? What would you be left with? 5x. So let's see. Oh, wrong.
Oh my God, that scared me so much for a second.
Yeah, the book's usually right. So is that what we got? Is that
Yeah.
essentially what we got? So let's go to the one that we were like, what the hell was that? Let's go to 11. Let's go to 11. Write it down, first of all. Write down the question. It's asking us to take the derivative of it. What's the golden rule? Change it into a fraction, so do that. What rule do you think you're going to use? Of those 4 rules, which one do you think you're going to use? Power chain. So use your power chain to do that. So you guys help me out. I mean, for sake of time, I would get what would be my coefficient? What would be the thing leading the way? 1/2. Then 3x minus 2 to the negative 1/2 times the derivative of this, which would be 3. Now let's look at their answer. Their answer was 3/2. Do we have that?
Yes.
This negative exponent, I could get rid of it by taking it downstairs, taking it to the bottom, and then be positive. And anything raised to the 1/2, the golden rule going backwards would turn into a square root. And you see how these two answers are the same. I want you guys leaving it like this. I don't want you wasting time on a quest. Turning it back into radical form. In fact, I don't ever wanna see a radical. I don't ever wanna see a square root, because I just wanna reinforce, turn every single fractional exponent into a power. What did I just say?
Every single fractional exponent into a power.
So let me give you an example, like down here, I think they only have one that I solved. Like this one. That's not the square root, but that's not the square root, but that's the cube root. So this, using the golden rule, would be 1 minus x squared to the 1/3. Then are you home free?
Yeah.
Okay. Now let's do some, anybody in here take any martial arts? Anybody ever take any martial arts? That was nobody. Anybody in here play a sport? Coming in here. Okay. Anybody play soccer? Anybody play soccer? Okay, good. Do they teach you like certain plays in soccer? Certain moves in soccer? Okay, when you're actually on the field, do you often have to like sequence moves? Do you actually have to sequence? Do one move that you learn and then follow it by another move that you learn? In basketball, do you have to know to dribble? But occasionally, do you have to know to dribble and shoot? Do you have to know? That was my problem. That was my problem. Not the shooting, that was fine. It was the dribbling that I guess was never very, and then the whole running aspect I wasn't very good at either. The whole speed, the jumping. Yeah, there wasn't anything about basketball I was good at. There wasn't anything. I guess shooting was kind of like my best weapon, was my shot. And that wasn't very good. But if I'm looking at one like number 31, does this look more beastly? How many people see a power rule in there? How many people see a power chain? How many people see the power chains going to be something that we're going to need? But we're not going to be able to get away with just a power chain. Because if I read this to me, you turn the math into English. X minus 1 squared
times 2x plus 1 to the 4th.
Okay, now what we're going to do is we're going to emphasize the word connecting the two of these. So let's try that again. This is f of x equals
X
minus 1 squared
times
2x plus 1 to the 4th. What rule, what flashcard do you have to use to start this? Product rule. Then you've got it like karate, so you're going to kick them in the chest, okay, with your karate kick, with your side kick, and then you're going to side punch them to the face, okay? So the kick to the chest is your product rule, and you're going to follow it by a punch to the face, which is your power chain rule. So I want you to try that one at your seat. Try that beast at your seats.
I was just thinking that.
Okay, just stop where you're at, wherever you're at. Here's the answer. They have two different forms. One would be 8 times x minus 1 squared plus times plus 1
Plus 2 times x minus 1 times 2x plus 1 to the fourth.
or this, which we would never do. Say that.
Or this which we would never do.
Okay, so now let's just try to see, how many people feel like they were on the right track? How many people feel like they were on the right track? Now guys, you do not have to do this intermediate step. You don't have to do this, but I do. Okay, you don't have to do it, but I do. If I wanted to take the derivative of this, the first thing I hit is the times, which means I gotta use product rule. In my product rule, which is over here, in my product rule, sorry. Who's playing the role of the F? Who's playing the role of the F?
X minus 1 squared.
Okay, and then this would be my, that would be my g of x. So if I'm looking at that, so it would be this guy's derivative, and I'm gonna write, you guys don't need to write this extra step, but I do. Derivative of the first times the second. No, I'm not worried about calculus at all there. What's the big connection sign in your product rule?
Plus.
The first, again, no calculus. Then the derivative of the g, which is that. So that's our sidekick. We sidekicked them with our product rule. Now we're gonna punch them in the face with our power chain. So let's do the power chain rule here. I would get a 2x minus 1 to the first times the derivative of the inside. But what's the derivative of x minus 1, guys? Just 1. This derivative of x is 1, that's 0. Then this guy has nothing. You can write him down. This guy we're done with. Now we come to the derivative of this. This would be a 4, 2x plus 1 to the third. Am I done? Am I done? What's the derivative of 2x plus 1? 2. Now look at that. Do you guys see we're really close? Look at that. Do you see we're really close to something that looks like that? How many people think they could do that? How many people they feel like they're pretty comfortable that they could combine that? Okay, maybe one more. Let's look at this beast. Let's look at 35. We've got f of x essentially equals x over 2x plus 1 raised to the 3 halves. Are you going to start with a punch to the face with this one, power chain, or are you going to start with another rule? You're going to start with power chain, and then you're going to have to take the derivative of the inside. But who's the f of x? Who's the f of x in this case? Is it, if it's f of x to the k, who's playing the role of the f of x? Yeah, the t divided by 2t plus 1. What rule are you going to need to do to take the derivative of that? Quotient rule. So again, it's a combination move, but you guys can do it. So go ahead, try that one. Try to attack that one. And I'll just write it as x. I'm not gonna breathe. Yes.
You look at mine, I'm like not certain.
Yeah, Alex, now just take those derivatives.
Okay.
Get rid of all those derivatives and you're done. Good. So guys, this is active learning. This is where it's different than me doing it and you writing it down. Do you see how your brain's more engaged? It's more painful with this. I mean, by you guys doing it, but you're also more alert. You're also more alert because you're not just scribing. So when you're teachers, I want you guys doing passive learning or active learning.
Active.
Active learning, okay, so that's. So people are like, well, people ask about what does it take to be a math teacher? They'll ask me. And I'm like, I don't consider myself a math teacher. And they're like, well, you're a math teacher. And I'm like, well, I don't consider myself a math teacher. I'm a coach. You know, that's what I feel like I do. I coach kids in math. Because coaching, the coach isn't really doing much of it. They're more directing practice. The kids are always on the court. They're always busy. Normally, guys, in my regular class, if we were there, you guys would be up moving around, in groups, out of groups. There'd be none of this where you just sit there and look at a distance. You'd be like together, working together, because I think it's the best way to learn. Okay, what are the two rules I need? What are the two rules I need? And looking at that, what are the two rules you need to take this derivative? Power chain and quotient. Which do I start with? Which do I have to start with? Power chain. Because I like to think of it, forgive me, I like to think of it as attacking a battleship. What the hell are you talking about? If you're gonna sink a battleship, you gotta attack it from the outside in. You gotta attack it from the outside in. So over here, I'm like the outside is that product. That's what I'm thinking. That's what I'm thinking. It's this function times that function. Once I blast away that outer deck, then I can get inside and use my power chain. However, here, this is a cruiser, this is a different beast altogether. First thing I'm seeing is I've got that power, so I gotta deal with that with my power chain. Who's the f of x? Who's the f of x? So let's see if you remember the rule. What's the derivative of f of x to the k? K times f of x to the k minus 1. So this is going to be, take this down and you're going to have a 3 halves times f of x, x over 2x plus 1, 3 halves minus 1 is 1 half. No, I'm not done. And I know you guys, some of you guys didn't need to do this extra step. But for some, it's nice to see the chain rule. It's nice to see the chain rule. X over 2x plus 1. Now notice at this point, this term's finished. It's toasted. There's no derivatives. This still has a derivative. Now I've got to hit it with a quotient rule. So I'm thinking I'm going to eat pizza for lunch. So I'm not even thinking, right? I mean, I'm just scribing. I'm just rewriting. Now I've got to actually think. If I think about my quotient rule, is it the derivative of the numerator or the denominator we start with? Is it the derivative of the numerator or the denominator? The numerator. And what would the derivative of that numerator be? 1 times the denominator, 2x plus 1. What's the connection sign in that rule, guys? What's the connection sign up there? Minus the numerator, which is x, times the derivative of the denominator. What's the derivative of the denominator? 2. All divided by the
Denominator squared.
denominator squared. Now on a quest, you can stop there. On a quest, you can stop there with this chapter. The next chapter we've got to simplify and use it. But on a quest where I'm just testing your ability to use these flashcards, the calculus is done. The calculus is done at that point in time. So let's just look at their answer, because I know they didn't do that. let's not panic, but let's just see.
Oh, they did.
Did we have a 3 halves? Do we have a 3 halves?
Yeah.
Well, we used X. Did we have the 1 half?
Yeah.
And do we have the right things set up there?
Yeah.
And then they simplify it. How many people are kind of understanding? How many people are kind of understanding? The nice thing about this section is it has quotient rule and product rule already built into it. So you're reinforcing all of these skills. You're reinforcing. What's the golden rule?
Always turn your square roots into fractions.
Change your square roots into fractions. Change your roots into fractions. That's not a derivative. That's not a derivative game. So one last one. One last one for this section. Ooh. Ooh.
Dr. Warren, no.
Let's look at this beast. Let's look at.
57?
Let's something more fun. Okay. Yeah, let's look at number 59. Yikes. Yikes. Grandpa's gonna fish. Grandpa's gonna fish. I'm Grandpa. If you didn't know, I'm Grandpa. I've got 3 grandkids. I haven't taken them fishing yet. Let me tell you about the time. Did I ever tell you about the time my grandpa took me fishing? Did I tell you about this? So my grandfather, when I was 5, you got to remember, and it might not surprise you that I'm a little hyperkinetic as a child and a little attention deficit. That may surprise you a little bit. Grandpa took me, being the oldest of 6 kids, fishing. It was in Ohio. We went to Lake Mohican there, and we were fishing. He was just teaching me. We took the aluminum boat off his old Ford Rambler, took it off, put it in the water. It seemed huge to me, this aluminum boat. We got all the stuff. We stopped and bought worms. We bought at the tackle store. We bought worms, and so we were out there. But he was showing me. He wanted to show me, and like how to fly fish, because that's what he wanted to do. He wanted to fly fish. And so he was showing me, we put the lure on there, and we were there, and he was just like, now what you want to do, grandson, is you want to just throw your arm just a little bit, use your legs too. You can make this thing almost look like a fly that's bouncing on the water, and you might get the bass to come up and actually bite it. So he was sitting there, he loved to fish, and he was so good at it. And so I'm there, and then I'm like, this looks easy. He goes, do you want to try it, grandson? I'm like, yeah, I'm going to try it, Grandpa. So I took that thing, and then being the spaz, I went, if it moves just a little bit, if you really do this, and this thing's flying all over. And the next thing I heard, and it was the only thing I caught that day, was Grandpa. And so he was flying, trying to protect his eyes from his spaz. He put his hand up and got the lure in his hand. And these are fishers. These people would actually fish. When you have the lure, when you have that barb in your hand, guess which direction it ain't going? Out. So he had to get the tackle box, take out his needle nose pliers, push it all the way through his hand, cut it off, pull it back out, put a Band-Aid on it, and then we picked up the boat, we got back in the car, we got everything else, bought the worms, and we went back to my house and he dropped me off. And went back to Columbus. So I learned something that day. That whenever Grandpa's fishing, it looks a lot simpler. Whenever Grandpa's doing it, it looks a lot simpler. But when you pick up the rod yourself, it's not so easy. And this happens in class all the time. Well, Dr. Warren, I really understood it when you were doing it. It's because Grandpa's doing it. Anybody who's ever fly fished before knows how hard that is and what an art that is. You put on your waders and you get in the water. There's no day better. Just saying. There's no day better. Even if you catch nothing on a nice day. I have a dream of going out west and fly fishing. But it'll never happen. I have 5 daughters. What does that have to do with it? Money. That's what it has to do with it. Daughters cost money. Sons cost money too. Daughters cost more money than sons. sons break your crap. Son's insurance go up. You're like, why is the man's insurance so much more? I'm like, have you ever had a son? I mean, holy heck. I mean, do you see what they do to cars? Daughters are just as bad. They just do it slower. Okay, let's look at problem number 59. So we've got this. I got my function, it's not little f, but it's
Big F.
big F. And capital F of x is equal to some other function they don't tell us what it is. It's an outside function. And then I've got this x squared plus 1. This uses something we call regular chain rule versus what we will use primarily in this class, which is power chain rule. And then what they ask me to find f prime of 1, knowing that
F prime of 2 is 3.
little f prime of 2
It equals 3.
is equal to 3. So this is what they want me to do. They want me to find capital F prime of 1, and the only information they give me is that f prime of 2 is 3. Now, power chain rule really provides the foundation of general chain rule. And let me just write this down. We're not going to use this too much in this class, but if you have a function, that's defined as the composition of two functions. What did I just say? I was almost knocked miles out. As I said, I knew the moment I said this, people were like, this brain's not going to listen anymore, Dr. Warren. I'm gone. I'm out. I'm done. I almost just went down there. Right now it's like Charlie Brown. You were wah, 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 wah. You don't know who Charlie Brown is.
What?
The teacher.
Oh, okay. So I thought you guys know. I didn't know. Okay.
Dr.
Still.
Warren, not like that young.
You know the show MASH?
Yes.
Really? I'm relevant. Okay. If you have a function that's the composition of two functions, forgive me, I like to think of it as a pregnant function. Because if you have a pregnant daughter, I'm sorry, my daughters are not 12, okay? My oldest is 35, my youngest is 21, the one who's pregnant is not the 21-year-old, okay? There's a human, and then there's a baby, another human inside the human. Does this make sense? I mean,
Yes.
are we like,
Yeah.
and do we realize this is probably a pretty complicated thing here? We got a mom and a fetus, and we want to take the derivative of that mom fetus thing. We got a mom. Oh, I don't think I started. Let me just see here. Am I filming?
Oh, no.
Yes, I'm filming. Which worries me even more. I'm gonna put this on YouTube.
So they're gonna get context about this whole.
Yes. So we've got a mom, I might have to edit this out. A mom and a fetus, and we want to take the derivative of a mom fetus kind of function. It's a lot like power chain rule. We've got the derivative of the outside function, which we know is like x to the k. You drop the k down, you subtract 1. It's like the derivative of the outside function. The inside some function stays the same, then times the derivative of the inside function. So in general, if you have a function where g is the mom and f is the fetus, I probably should have called this m, mom, fetus, it works like this. It's the derivative of the mom function. It's the derivative of the mom function evaluated at the baby function. But it's just like chain rule. This is general chain rule. Then you multiply it times the derivative of the fetus. So it's the derivative of the mom evaluated at the derivative of the mom function evaluated at the fetus function times the derivative of the fetus function. And this is what's going to help us here. Who's the mom function and who's the fetus? Who's the fetus function?
X squared plus one.
X squared plus 1. Who's the mom function?
Little f.
Little f. And so if I take the derivative of this, it's going to be the derivative of mom evaluated at
The
the fetus, and who's the fetus?
X squared plus one.
X squared plus 1 times the derivative of the fetus. What is the derivative of x squared plus 1? Hopefully everybody here has that. 2x. So this is going to be equal to f prime evaluated x squared plus 1 times 2x. We're using general chain rule. Which is this here. I'm not even writing it down as a flashcard in this class. I'm not even writing it down as a flashcard. We're going to use it so infrequently. But I do need to teach it. You're like, Dr. Wood, they didn't give us f. They just gave us little f. There's no way we can answer this. What's the only information they gave us? What was the only information they gave us? They told us that little f prime of 2 was 3. And they want me to find capital F prime of 1. But we're in better shape. Capital F prime of x is equal to f prime of x squared plus 1 times 2x. This would imply capital F prime of 1. Wherever I see an x, I'm going to put a 1. What did I just say? I'm going to say that one more time. What did I just say? Okay, so if I'm looking here, do you see an x? I'm going to put up 1. F prime of 1 squared plus 1. Do you see an x?
Yes.
What am I going to put?
1.
Times 2 times 1. Well, what's 1 squared plus 1? 2. What's 2 times 1?
2.
So this is equal to f prime of 2 times 2. But what's the only piece of information they gave me? They told me little f prime of
2
is
3.
3. So this is equal to 3 times 2, which would be 6. So this is general. This is an application of general chain rule, which I felt like I needed. Yeah, we're doing it. We're finishing with this. We're finishing today with this. How many people were okay Grandpa fished that? How many people were okay with Grandpa fly fished that thing? Okay, if I look at my time, I've got 5 minutes. So I think Grandpa's got to fish this thing. But you guys could do it. You guys could do it. It would take you 10 minutes, it'll take me 5 minutes. It would take you
10 minutes.
to get your lure on, to get the worm on. First you'd be like, gross, I don't want to touch that worm, yuck, I don't want to. This is why I don't go fishing with my daughters. They're like fine about catching the fish and getting it in the boat, but that's it. I get to put the lure on, I get to bait the thing, I get to clean the fish, I get to take the fish off the hook, I get to cook the fish. All they do is catch the fish. That's all they do is catch the fish. So just saying. That's not quite as much fun. It was like, I also thought I'd throw a football for my daughter. I mean, I always, when I was a kid, I envisioned like my son being in the yard with me and us throwing the football back and forth, father, son. Then I had my first daughter. Then I had my second daughter. Then I had my third daughter. Then I had my fourth daughter. And I saw with somebody who said we would never have any children. I'll never have a child. Then, by the fifth one, they looked at the ultrasound and went, yeah, I've seen that picture. Okay, that's not a boy. That's not a boy. And I thought one of the five would just, do you wanna go throw the football? Nope. Do you wanna go throw the football? Nope. Do you wanna go outside? Nope. Okay, so yeah, just saying. But now I've got grandsons.
Do they wanna throw the football?
No. They play soccer. I'm just like, what? Okay, but back to where we were
We
here.
took an L on that one.
Okay, this says, find the equation of the tangent line. Find the equation of the tangent line to this incredibly challenging function. You're not gonna graph that. Find the equation of the tangent line at the point 315. Tough question. Find the equation of the tangent line. When I say tangent line, you say,
Y minus F of C equals F minus Y
y minus f of c equals f prime of c times x minus c. So I know I'm gonna need a derivative, of the function, and I also need a c. Now you guys help me out. If you were facing this, who would you guess the c is?
3.
The x coordinate. Who would you guess the f of c is? 15. Let's just make sure they did it right. Let's make sure the book. If I plug 3 in here, I get a 3, 9, 18 plus 7 is 25. The square root of 25 is? 5 times 3 is? 15. So I know that I have y minus f of 3 equals f prime of 3 times x minus 3. This is 15. I almost say this in jest, I almost laugh. The only thing I need now to get the tangent line, the only thing I need now is the slope, which means I gotta take the derivative of this beast. Am I going to need the golden rule?
Yes.
I would change that square root into a 1/2. So I'd have f of x equals x times 2x squared plus 7 raised to the 1/2. Is this going to be a multi-move karate move or a single move karate move? If I'm taking the derivative of this, is this going to require more than one flashcard to take the derivative of it?
No.
It does.
Oh, there's the X in front?
This says x, x,
Times.
x times x. So you gotta use what rule? You gotta use what rule? Product rule. So let's do that. I'm gonna bring this plane down. I'm gonna crash it. Okay. What's the derivative of x? I'm gonna do this all together. What's the derivative of x? 1. There's the derivative of the first times the second. Am I done with product rule? Plus the derivative of the first times the second plus the, I'll try that again, maybe with more energy. Product rule is the derivative of the first times the second plus the first. So who's the first? X. Okay, now the derivative of the second. What rule am I going to need to take the derivative of the second? Power chain. Who's the power? So I'll have 1/2 2x squared plus 7. Now this is the hardest part of the whole problem. What is 1/2 minus 1? Negative 1/2. Am I done with power chain?
No.
What's the derivative of the inside?
4x.
4x. Now comes the worst part of the problem. Getting your calculator out. You need f prime, not of x, you need f prime of 3. So then you're just gonna have to, wherever you put this, and I'll do it quickly, it's gonna be 1, this will be a 5, this will be a 5, this is 1/2, this is 1/5, and this is 12. I'm not taking any further than that. That number goes in there. How many people like me? Guys, this is one of the hardest sections. How many people like they feel like they've got some control over this section? Okay, I'm gonna put up homework, in this section, and that's what I want you focusing on. What's due tonight at midnight? WebAssign, 11:59, sorry, 11:59. I always am not sure, is it AM or is it PM? I should know. The last thing I wanna have it do is at 12 AM on the day, like, so I always go 11:59. Okay, have a safe weekend, Thanks for coming out.
It's Friday, I'm done. Well, I mean, I still have a religion class, but like, I'm done with it.
Parker.
No.
What's your name again? Zach?
He doesn't really give us any terms, he doesn't give us any conclusions, and he's like, I think that's what.
Noah?
And the first one, it was just like so that we could do it, so we got it like in 100 days, no matter what score we got.
Shay, all good, all I'm kidding.
Oh, that is an ugly noise.
Mason. Miles.
Wait, Dr. Warren, do we need to know
Zach.
that?
Yeah, you got it. Oh,
I keep saying Zach and no. Trey. Is that right?
yeah, that's
Okay. Alex.
Do we need to know that little equation in the box? You said that it's not a technically a flashcard, but we're still gonna use it sometimes, right?
You're gonna use it at some point in time, but every time I use it, I'll bring it up.
Like you'll give us the equation for that one?
I will make sure you have it. If you need
Okay.
it, the most important rule is the power chain.
Yeah.
That's the thing that we'll just keep going back to over and over again.
Okay, so if it's on a test, we'll have the equation.
If you're on the test, you'll have the equation.
Okay.
Dr. Warren.
And it won't be on the quest. It won't be on the quest.
Okay.
And what's your name here again?
Lorelai.
Lorelai.
You got it.
Lorelai. I'm so used to seeing you, Lorelai, without your mask.
I know,
On the-
and
on
my
the-
name
on the-
is like right there. Should we write name tags for you?
Yeah, that would be Lorelai.
Lorelai.